So now let's look at some problems that apply perpendicular bisector theorem, which says if a point is on a perpendicular bisector, then it is equidistant from both endpoints of the segment that was bisected. And here we see in this first problem that point D is on a perpendicular line, and it is indeed equidistant from both endpoints of the segment. Therefore, B has to be a midpoint, and AB and BC are the exact same length. Since AB is 80, BC is also 80. You're looking at the second problem now. Feel free to stop your camera, work through your solution, and then come back and compare. For this next problem, we're given KH here on the left equals SH on the right, which means they are both congruent. So I'll put tick marks on them. And they both equal 97. So we'll insert that into the picture. KM, from the midpoint here back to K, is 3 T units long. And SM here is T plus 60 units long. Since this is a midpoint, we know it is because this point is equidistant from both endpoints. So we are using the converse now. Since it is a point on a perpendicular bisector, well, we didn't know that. We know it's equidistant from both endpoints, therefore it is a perpendicular bisector. So we will mark it as perpendicular, show our parts as congruent. This half on the left is equal to this half on the right. So we'll write an equation that says 3t equals t plus 60. Since we have more t's on the left than on the right, I'm going to eliminate this one on the right by adding the opposite of a positive t, would be subtracting a t. What I do to one side of the equal sign, I do to the other. That gives me 2t on the left equals 60. They want to know what t is. I need it by itself, so the opposite of multiplying by 2 is dividing by 2, and it cancels. What I do to one side of the equal sign, I do to the other, and I end up with t equals 30. If you understand, feel free to move on, but if you want more examples, I have a couple more set up. This question says, can you use the perpendicular bisector theorem to find VW? So let's look. We have a point. It's on a bisector, but we don't, and we know it's, we have a point, it's on a perpendicular line, but we truly don't know if X is the midpoint because they haven't shown us anything about congruency for the two segments or equal lengths for these two segments. If we don't know that these are halves, it doesn't matter that that's perpendicular because W could be a little bit longer out here. So this one is a no. We cannot predict the length of VW because if we could, we'd have to know something about these two segments on either side of X. We'd need congruency marks or we would need lengths written in there. So the answer is no in that scenario. Turn off your camera or your video. Think about it for a minute and you can ask questions if that does not make sense. The last problem here wants to know the value of S. So let's make sure we have a point and that it's on a perpendicular bisector. It definitely is not on a perpendicular line. Oh look, this tick mark here and this tick mark here do indicate that the distance here from the center to the right point is the exact same as the distance from the center to the left point. Therefore, that point here is on a perpendicular bisector, and we can say 6s minus 34 has to be the same length is 8s minus 78. We have more s's on the right, so let's eliminate these on the left by adding the opposite. The opposite of positive 6s is negative 6s. What we do to one side of the equation, we do to the other. Let's also, since we always want our variable on its own, get rid of this negative 78 by doing the opposite. Add a positive 78, and if you do it to one side of the equal sign, you must do it to the other. I know some of you like to do this line through. 8s minus 6s will give you 2s. let's see, we have minus 34 and plus 78. That's going to leave us with 44 equals 2s. We still need s by itself, so divide by 2 gives us s alone. We do that to one side of the equal sign, we have to do the other. And now we know that s equals 22. That gives you some examples of how to work perpendicular bisector problems.